Hi guys! This lesson will be about the gradient-boosted decision trees. This algorithm is considered to be the best general-purpose algorithm for solving classification and regression problems. Of course, in some particular areas like computer vision or speech recognition, there are algorithms which are more suited to solving some particular problems, but in many real-world applications which you will face while working as a data engineer or data scientist, gradient-boosted decision trees is the method of choice. First of all, what is boosting? Boosting is a method for combining outputs of many weak classifiers to produce a powerful ensemble. There are several variants of boosting algorithms: adder boost, Brown boost, logit boost, and finally gradient boosting, which you will learn during this lesson. When you work with big data with big training datasets, they have, on the one hand, a large number of training examples, and on the other hand, a large number of features describing objects. In this situation, it is very natural to assume that you would like to train a really complex model, even having such great amount of data. And hopefully this model will be accurate. There are two basic ways in machine learning to build complex models. The first way is to start with the complex model from the very beginning and fit its parameters. This is exactly the way how neural network operates. And the second way is to build a complex model iteratively. You can build a complex model iteratively where each step requires training of a simple model. In context of boosting, these models are called weak classifiers or base classifiers. We will proceed the later way. Consider for simplicity a regression problem where you have a training set which consists of pairs xi, yi, where xi is a vector of real-valued features and yi are labels or targets. And our goal here is to find the function fx such that the squared loss on the test set will be as low as possible. So you train the model using only the training data, but you expect that the error at the test data set will be low. How to build such fx? In boosting, you are going to build the function fx iteratively. You suppose that this function fx is just a sum of other simple functions h, m, x. And particularly you assume that each function h, m, x is a decision tree. Okay. Here is an algorithm for training gradient-boosted trees for regression. In the input you have training set, and capital M is a maximum number of iterations. At the first step you calculate an average of all the targets yi, and it is your initial approximation to the function fx. And then you repeat line from 3 to 5 for capital M iterations. What do you do at the step number 3? You calculate the residual. What is it? Residual is a difference between the target yi and our current prediction fm-1 xi. And at each step you are going to minimize this residual and train a new decision tree, such that it will fit this residual as close as possible. Informally speaking, you create an auxiliary training set which consists of pairs xi, y hat I. It is equivalent to the original training set, but you replaced the original labels yi with residuals. At the step 4, you fit a decision tree HMX to this new target of residuals y hat I. And finally, at the step number 5, you add this decision tree to the composition. But you multiply it by a constant nu, which is called the regularization or learning rate. This constant is recommended to be small and particularly less than 0.1. Okay, if you are familiar with the optimization theory, you may have noticed that gradient boosting is somewhat similar to the gradient descent in the optimization theory. If you want to minimize a function in the optimization theory using the gradient descent, you make a small step in the direction opposite to the gradient. Gradient of the function by definition is a vector which points to the direction with the fastest increase. Since you want to minimize the function, you must move to the direction opposite to the gradient. To ensure convergence, you must make very small steps. So you are multiplying each gradient by a small constant, which is called a step size. It is very similar to what you do in gradient boosting. And gradient boosting is considered to be a minimization in the functional space. Okay, the summary of this lesson. You have learned what the gradient boosting algorithm is. Boosting is a method for combining outputs of many weak classifiers or regressors to produce a powerful ensemble. Gradient boosting is a gradient descent minimization of the target function in the functional space. Gradient boosting with decision trees is considered to be the best algorithm for general purpose classification or regression problems.